interesting
This
things there.
conference will now be recorded.
We focus on at least understanding how every implementation class works, at least the very important classes. I am thinking at least we are going to again discuss some 15 to 20 classes in this hierarchies, okay? If they were there, if not, the core and important things. So now there are so many things that are available here, friends. Yesterday we have done till this point, and we have seen like working on lists, the methods of lists, how to create lists, or how to append, how to prepend, and all that stuff. Okay. Now today what we do is we will just quickly walk through these methods. What are those methods? Filtering methods. And I'm not going to take much time here because these are, you can understand most of this. Filtering in sense, right? That's clearly understandable. How to remove elements from a list here. Filtering is that, right? Like if you have a tea, you prepare a tea, you do some filtering by applying that filter, so that something unnecessary is removed, something necessary is that goes into the glass, or that whatever vessel you want to put that tea. Similarly here also it happens same. So, and one more thing is, right, as this is immutable, even though you apply filter, then the result you have to initialize to some other variable. Why? Because we cannot modify exactly the existing one. But what happens internally, every time you try to modify this immutable objects, a new object is created. This discussion is done when I had explained about the string topic. If you remember, we had drawn a diagram and we have seen the process, how it happens. The same is applicable for any kind of immutable object. It's not just for string, but we can apply this for even a list, as well as even for immutable sets or immutable maps. This concept of immutability doesn't change. Okay, that is fine. Like what are these methods here? Right. Let's just quickly see this, so that because there are so many things in collections, and we need a little practice also while jumping to the Spark. And for me, if you ask me, once you finish this, you find Spark is much more interesting because I like Spark a lot, the talk concepts and the depth of the concepts, and the variety, and that will be much more interesting if you start working with Spark. Definitely, trust me, you fall in love with that. But before that, if you are really good with one language, you can enjoy that more. So these methods, when you look at it, there is nothing. Just I don't take much time. Distinct means it returns unique elements from a list. Okay. So drop means it will remove something and return other things. Drop of n means return all elements after the first 10 elements. We'll see that with examples. Okay. Drop right means it will drop only the right elements. Drop while you apply a loop, and you apply a condition here. Based on that, which should be dropped, that will do that. Filter means it will remove the elements based on the predicate means condition you apply here. Filter not which you don't want to filter. Find what is that you want to find, whether an element is there or not. That's it. Return the first element that matches the condition. Okay. So head returns first element. Tail returns, right? Yesterday also Bharat has asked me a question like, what is the tail for? Except first element, all other elements are written. We can see there. Filter not, okay, find head. Okay. Head option means this it returns first element as an option. And about the story of options, sum and none, right? You remember, right? So that returns as an option object. That option internally returns a sum or none. So init means all elements except the last one. Intersect, return the common, right? This is clearly understandable. So returns the intersection of, it means common elements generally. Okay, last means returns the last element. And also one other important point is, can throw an exception if the list is empty, because element should be there, otherwise you get an exception. Last option, instead of returning it as some element, it returns as an option. Slice means, what is slice? It is a part of a list. We can cut it into parts. Okay, and it has a start index and end index. Okay, so that's what this slice is. We work with all that. Tail Tail means, right, all elements except first element. Take. Take means the first 10 elements. Take right. The first, the last 10. Right means rightmost. That means the last 10 elements. Suppose if you say take right of two, last two elements. Take while. Again, which elements you want to extract from the list based on the condition of like. P means predicate. Predicate means condition. Nothing more than that. So I know I had just gone a little fast, not because I want to, but by looking at those methods, you can easily understand what each method is doing. Still, if any confusion here and there is there, then let's understand here by looking at the code. Okay, we can quickly analyze the code here. Based on the code analysis, you can easily understand what each method is doing, and we don't need to waste much time because there are so many things to finish. So what I will do is I'll copy all the list of methods. Just see the list, what list is there. Then we will analyze the method and the output. By that, that will definitely make you understand how each method is working, or the behavior of each method. That is more than enough for us. Okay. Later on, while we are doing some problems, we will also do some implement some use cases. Maybe you can choose whichever you want. That gives more practice to all of you. Okay. Okay. So, and right, when you look at these methods, let me tell you, let me copy and paste here. Most of these methods you will see in Spark also. You're going to watch them in Spark. Okay. I'm removing this not to have any confusion with variables. Okay. Because you know all this stuff and it is recorded anyhow. I'll upload it today probably. So, folks, I'm just trying to paste here. I don't think you need any serious introspection on these methods. And also you can see a couple of things you can see. Somebody asked me sometime like, composite methods, method inside a method here, if you see this, or, these are all, wherever you find bracket operators, these are lambda functions. Internally, they are all lambda functions. Okay, see, we are passing a function as a function, and we had discussed one name there. You remember, right? Sometime back. So so this is the power of Scala, right? So now I'm going to run this. So let us analyze the output. Okay, what happens here? What is the output you should get here? Distinct means 10, 20, 30, 40, 10. You get excluding 10. You get only one 10, not two tens. Drop to means drop n elements from a list. Means n might be first or last elements. Probably I'm expecting the first two, 10 and 20. Okay. Drop right means probably rightmost elements. Okay, rightmost two elements. Let's run it and analyze it instead of checking like this, so that you just, when you compare it, automatically you get a clean idea. This is actually the distinct. The second one is a drop of two. You can see the first two elements are removed. 10 and 20 are gone here. Okay, 1 minute. Yes, correct. 10 is in the second case, duplicate is still allowed. It's not distinct, right? In the third case, again drop right. So this is original list actually. Drop right means rightmost two elements, 40 and 10 are gone. And then again drop while. Drop while means you can see in that here, if you look at here, which are the elements that are less than or equal to 25. All those elements are going to be removed here. So drop first sequence of elements which matches the condition. So in this 10, 20, 30, 40, 10, you can see less than 35. What are less than 35? 10, 20 are less than 35. 30 and 40 are remaining. So you have 30, 40 here. Okay. So likewise, filter written all elements which matches the predicate. Whichever are greater than 30, I need them. That's what this filter is doing. Okay. So which are greater than p greater than or equal to 30. This one, right? This is 10, 20, 10. 1 minute. why you are getting this? You should get P arrow mark P greater than or equal to 30. Then, okay, I think somewhere,
Man- Manohar,
yeah, yeah.
8 drop while less than or equal to 25, it's written in 10 also, last 10.
Okay, okay, got it. Yeah, I understand. This is the, that's, then it's clear. Okay. Here, if this is coming for drop while, there is nothing wrong in that, because when you apply this drop while, it's clearly saying that drop first sequence of elements which matches the condition. What are the first sequence of elements here? 10, 20, not last sequence. So after 10 is coming after 30, 40, so it will check up to the bigger number here. Once if that condition is failed, it doesn't check for the next elements after these bigger values. That's what happening here. If that is the case, then we are good, because this is, if drop while is giving this, okay, and this is a drop right, okay, then this is perfect. We don't have an issue. That's what I got stuck here. I was little confused with this, if this is giving filter, no issues. Okay, fine. Then you can see this is giving us all numbers which are greater than or equal to 30, then 30 or 40. That is perfect. We are good. So is your question answered, Bharat?
Yeah, yes.
You understood, right? It will only check for first sequence of elements, Bharat, not everything which is less than 25. Got it,
Got
right?
it, got it. Yeah.
Okay. Only first sequence. In the first sequence, 10, 20 are less than 25. That's why you see here 30, 40, and 10 is also present. Means it is giving right output. We don't have an issue here. Okay. Filter not, which are not greater than or equal to 30. Then probably 10, 20, 10. That is filter not. So that's perfect. Find if P is 10, anywhere if you have 10, then you can see there it is giving us an option here. When you say sum of 10 means it's giving us option. We don't have an issue. From option, we are applying get method. You know all this, right? How to get an element from some, right? We can apply get on that. We had discussed this in the very beginning. So head means, right? Just returns first element. We got 10, and then tail means, okay. So if you look at it, we are just only comparing, sir. If anybody has any doubts on this, just stop me there. So that we can quickly, clear the doubts and go to the next one. Because there are so many methods, we should not stuck in these methods for a week again. Let's finish it probably. Let's try to finish today. If not, tomorrow we will finish up this. So head is 10, good. Tail except first element remaining are coming, good. This is tail. Head option, yes, correct. First element, giving it in the form of option. Option returns some if element is there, otherwise none, you know that. And then init means, right, return all elements except the last one. So 10 is missing. We got all the elements except last. And then comparison, intersection. Correct, right? In this we have two lists, L1, L2. We get all the common elements. Between these two, the common elements are what? So we have 3, 4, and 5 here. These are the common elements. That's what it is showing here, correct? So that is perfect. And again, last element returns last here. So even 10 is last element there. So we are getting that. Last option means again last element which is written in the form of option. We are almost done with the method, sir. If anybody has doubts, you can raise it instantly. No need to hesitate, okay? Because I told you, right, looking at the methods, you understand what each method is doing, because head means first element, tail means except first remaining things. That's so easy to understand. And also slice means, as name says, mango slice, apple slice, like that. Here also we can slice our list. Slice of 2, 5 means what it gives us. It gives elements from 2 to 5 here. You can see there 30, 40, and 10. Here seems like 2, 5 means, right? What is the list here? List has how many elements, sir? List has 5 elements. Index comes up to 4. This is, right, sir? This 5 is exclusive. there is no fifth index. It will take up to 4 only. Got it right? Because 5 is exclusive. Keep in mind, it doesn't take up to 5. It will take 2, 3, and 4. Take 2 means this is these methods like take right, like these methods, these are called actions. These are called as actions. Most of these are actions, sir. Whatever you do, collect or drop, these are called as actions. Actions means which perform something on your data, and it will give you the fetch you the result. That's called an action. Okay, so when you hit someone, immediately what happens? Something happens, some result will come, right? That's action. Technically in Spark, these things are called actions. Okay, and there is one more thing called transformations. We are going to see them now, which changes data. Or transformation is something which gives you a collection from another existing collections. Okay, so here take is something like which gives you the first 2 elements here. Take off not 2, whatever you specify here, that gives that first 10 elements. So that's what happening here. You got 10, 20, right? Then take right last 2 elements 40, 10, and then take while it checks this condition. What is that? It gives all elements which are less than or equal to 30. Then you get 10, 20, and 30. Are you good, sir? All of you? I think I was.
Manohar, yeah, it's good, but I just want to ask you one thing. Earlier we have used val x equal to a dot find,
Okay.
and there we are using println x dot get. Why dot get? And yes, that one.
This one actually,
Yes.
so let me remove it because this is something which is an option concept. Option. You have idea about option, right, Bharat?
Yes, 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 we do.
So if you see this, here, suppose let me just show you without saying x dot get. Okay, let me
It's
print x.
showing sum of
Correct,
sum of
correct.
10.
So this is this find method returns that result. It is finding it. It returns an option object. What object? Option.
Okay.
And when it is option, from option, either we get some if element exists, otherwise none if there is no element exist.
Mm-hmm.
So let me show you. So let me just show you here, just analysis. So probably if I am not wrong, you missed that session, correct?
Mostly different
That's
because I'm.
yeah,
That's why
yeah.
I'm not getting this point.
No issues, no issues. I'll just show you quickly. So if you see there, when I put option here, let me give some space as well, just to highlight that particular scenario. I put option before that. It is giving us what option has 2 subclasses. One is sum, the other one is none. Even though we get option object, option returns 2 subclasses, either sum or none. When we get sum object is if element is present there or if element is there, then it returns sum. Like this, it will add that data to that sum and it is returned. If no element exists, if it is not returning anything. So if suppose I say 100 here, see here, if I do this, now you got here, where is that none? You got none here. Can you see there, Bharat? Can you see
Sorry,
here, Bharat?
I went on. Yes, yes, I went on mute. I got it.
So means what? If condition is satisfied and if element exists, it returns some object. That value is put into that sum and it is returned.
Mm-hmm.
If that condition is not satisfied or if no element exists, option returns what's a none. So
Okay.
that is a high level understanding. I'll share you the option clear. We have done a lot of analysis on option. I will share that video. Definitely that will give
Okay.
a crystal clear analysis on option. Okay.
Okay.
Now,
Thanks, Manohar.
the point is from this, right? I cannot directly every time I cannot use that object sum. From that sum, I should get that value. So how do I get it? So on top of it, I should say get. this get will get that value from the sum. Okay. Now if you see there, you got 10 here. This time you didn't see sum of 10, but what you get? You get just 10. Why? Because x returns sum of 10. From that x, I told to get will return the value from the sum. That's what this is doing.
Okay. If that value is, for example, earlier you put p equal to 100, right?
Correct.
If that value is not there, then what will you use? X dot?
In that case, you don't need to apply get, because it by default returns none. None means nothing is presented with option now.
Mhm.
Returns sum, then only we apply get on that, get method on that. Otherwise, no need to apply any method, because on none, applying get is not a right choice. Bharat. Suppose this is
Okay.
what. Okay, so you try to do
Mhm.
this. Can you see there what happened?
It's throwing an exception.
It's clearly saying what is it?
Yes. No such element exception.
Because none is returned when option clearly know that there is no element present. So when find condition is false, then it cannot return anything. It cannot return that value. So it returns none. On none, applying get is like trying to milk a buffalo which doesn't give us a milk. That's all. Simply.
Okay. At that time, if in order to not to get this exception, what can we print? X dot anything? We can't do
That's
anything.
what, right? So you know that, see, when you print text by then itself, if it is not, so usually we apply again a kind of a check. What is that? Whether it is returning some or whether it is returning none with this case construct, Bharat. Because
Okay.
to avoid this kind of exceptions, again you have to handle it right.
Hmm.
Because right, definitely in a project, when you are doing a project, you don't know whether you get some or you don't know whether you get none. In that scenario, we take more precaution by taking that case class and passing this parameter to the class. If it is some, we say that return that value. If it is none, okay, just we'll make sure that it is clearly returning none there. Then we do some kind of condition checks. Got it right, Bharat?
Okay. Oh, got it. Got it.
That's how we progress. So, and we don't have a issue there. Definitely we will apply a precaution, a filter again on top of this. Okay.
Got it, Manohar. Got it.
So, and my point is very clear. Apply get only when you are seeing some object, because right, anyhow you test before committing that, right? So definitely when you run it, you understand whether we are getting some or not. Still we have a benefit of doubt, then we can go for case construct and do the choice checking, right? We have case one, we can put some and test it. Case two, we can put none and test it. If it is getting some, okay, we do something. If it is getting none, we do something. That's how we proceed, Bharat. Okay.
Thanks, Manohar.
Yeah. Any other questions, Madhu? And
Yeah, I
then
have one question.
who is it? May I know? Sandeep?
It's me, Sandeep. Is
Yes,
it
Sandeep.
possible to
Yes.
handle those exceptions?
Yes, Sandeep. Without, definitely we have to put all this code in try block code, try catch code. Okay. We don't just do
Oh,
this like this. When you go for a project implementation, try catch is one of the most common practice you have to implement. Okay.
okay.
And also not just
You-
try catch, you take necessary condition checks to make sure that your code is robust. Robust means it's very strong. Okay.
Yes.
Yes, that's the point.
Okay,
Let's
thank
finish. Maybe I can show you the best practice. These are all called best practices, applying best practices. So if we should go for applying best practices, first let's have some basic understanding. Later on we will develop a use case applying all these best practices, so that will give you a clear idea. Okay. So folks, why don't you test this quickly, so that I will switch to the next set of methods. I'm sorry. I that's actually an involuntary act happened. So we have done filtering, then we do update quickly. Some methods will keep recurring, right? You can see distinct is again coming back. And these are all again very important methods. This collect, this flat map, this union, this sequence. Okay, sorry, not sequence, union, and then flatten, flat map. You see all this in Spark again. Trust me. In this, we are going to see all this again. If you want, I'll quickly, maybe not every time you might see head or tail, but filter method you are going to see, sir. Drop method you can see, and last, it may or may not. Take method you can see. Just just I'm just giving you a heads up on what methods you keep. They keep recurring again and again. I don't say that other methods don't come, but this recurs a lot. When you are working in a Spark project. Okay. So remember, drop, more than drop, filter. Filter is quite common method you keep seeing in your code, okay? And then find, sometimes not like the extent of filter, and also take is an action again. These are all probably, most of these are actions, okay? A filter is not action, okay? Right. So filter is again transformation. Maybe you can ask me a question. How do you know difference between transformation and action? It's not so difficult. Transformation means it is something which already there is an existing collection. From that collection, it will generate one more new collection. That is transformation. Action is something which will directly produce some result. That's what we call action. Okay. So next, finally, update. Again, one more question. You can see there again a precaution is clearly stated. Because list is immutable, you cannot update elements in place. That is true. No, who will object that? Okay, who will oppose it? Nobody. But depending on your definition of update, there are a variety of methods that let you update a list as you assign the result to a new variable. That is also a very important point. If somebody asks you this question, you can tell them, "Arey, definitely we are bounding to the rules of immutability, but whatever I get the result, I am assigning to new variable. Then the immutability still is intact. We are not modifying the actual one. It's not possible. Even if we do that, it will internally create a new object, get the address of that new object, and is assigned to this reference. At program level, it seems like you are modifying the original one, but at my memory level, you are not modifying original. Original is still intact, but a new object is created. It's like, just to remember, don't take me wrong, like right, you already, a person is married for one time. Marrying for second time means he'll be in one house first, but after second marriage another new house comes. Marriage concept is same, but house changed here. Got it, right? Reference is same, object get modified here. What's point here, right? So that's all. Might be, if it is little funny, you can enjoy it, otherwise you should excuse me. Just to remember only, okay? So let us
Yes.
quickly.
Thanks, Manohar, for a quite resemblance of the sequence.
Okay, right. Please test it. Then I will just quickly move to the next one. Okay. We will do update methods. Okay. See, I think we got a clarity on this. See, anywhere you do filter, update, or anything, don't think that you are modifying the original object. That's not possible. Immutability means, clearly. I have shown with diagrams in string concept. If you have a doubt, go to that video in the beginning, not now, in the beginning, somewhere in the beginning sessions. You get an idea. Right. So first test it, then I will switch to these methods. We will finish off this also if possible today. Please test it. So Madhu, following, seems today we are making it little. Please confirm, sir, once you are done. Please confirm, sir, once you are done. Also, I put it in the methods in the chat box so that you can use it as a backup. If you miss anything, still that might be helpful for you, for all of you. Please confirm, sir, once done. I'm waiting for your confirmation. Then we will switch to the update methods. They are also very useful. Okay, Srikanth. How about others, sir? Please confirm. If I should wait, just anybody has a problem, just tell me, I'll wait. Otherwise, I'm moving to the next one, update. Okay, thank you. Seems like most of you are done. You can stop me, sir. You have that freedom. You don't need to feel like I'm moving. So you can see here now. Next set of methods are these, sir. Probably I can say these are most prioritized methods. Tomorrow, when you look at Spark, otherwise, even after this class, go ahead and check Spark actions and transformations. Definitely, under the transformations, this flat map, filter, okay, flatten, and then this union, all this will appear. And collect these actions, sir. What is that? Collection is an action again. Action means I told you clearly difference. Transformation is something which creates. Can you see? You can see there. Flatten. Transform a list of lists into a single list. Means it is giving one more new list. Flat map. Flat map means, sir. See, one more important point, sir. Maybe none of you have this question. Nobody asked me this question. All right. If this filter, this drop, this all these guys, right? Many of these methods. Every method is internally have iterators. What they have, you see, you say filter, you say drop, right? You say drop. Okay. You say distinct. Internally, you say head. You say tile. These has, you say take. These has internally iterators, because if there is no iterator, it cannot directly go to a specific location and get or try to get some elements from that. It's not possible, sir. You have a iterator internally implemented in all these methods. Remember, okay? So likewise, even this filter, this map, this collect, okay, flat map, these are all iterators, sir. Intelligent iterators. Where instead of you putting more effort, this will help you to do that. If you are really interested, we can design these methods ourselves also. We are good with the basic looping thing and basic functionalities. Okay, fine, no issues. Maybe if you want, we can try also if you have that interest. So, what are all these now? Look at this update methods. Collect. These are also iterators. What they does? Collect means it will give collection of all elements. When you say collect of, right? It's more like you apply a predicate here or a partial function. PF means, and then based on that PF, that logic inside that PF, it will give some elements from that. Okay. And then flatten means distinct means, sir, we had already used this today. Flatten means, suppose, right, when you have a list of lists. Some yesterday I told you clearly, even I mentioned this point yesterday, if you remember. What is that? It's like, when you say plus plus, you remember, right, this discussion. When you say colon plus or plus colon, right, when you try to add a list to the with colon plus, it will add list as an object. I told this point clearly yesterday. If you apply plus plus, it will merge two lists into one list. You remember, right? I told you this is something like a flatten. You remember? Flatten is that. Flatten means just it will straighten everything. It doesn't add a list as a list object, but it will fetch all the values from the list, and finally it will add those elements to another list. You got my point, right? That's what transform a list of list into a single list. Means you have multiple lists, list 1, list 2, list 3, and elements in each list. All those list of elements is converted into a single list. We can see the example that gives you a clarity. Flat map means applying map and flat map together. Might be you can ask, what is map? Map is, again, I think we had a discussion, right? Map is something which we apply some a condition, or not condition. We modify. Map is applied when you want to apply a logic on every value present inside a collection. Suppose I have a collection of 5 elements, like 1, 2, 3, 4. I want to apply a logic on each element. I want to iterate each element and apply a logic on each element. Then you have to go for map. Got it, right? So what map does? Iterates each element of a collection, then apply a business logic. That's what map is. Flat map means what? Suppose if it will apply flatten plus map is flat map. If the map right, when you apply flat map on some collection like list, okay, it has a list of lists. First it will do what? It will do the flattening on that list, and then it will apply the map iteration. Map will what do? It will try to modify every element existing in a list. That's what map is. You have a function applied from on map, then that function is applicable for every element in that list. That's what you can say. Return a new sequence by applying the function to each element. That's clearly saying that. Okay. Updated. Update means, right, sir, it will update new element with old element with new element. That's what it will do. I don't think we need a big discussion. Union means, right, it will add two elements, two lists into one list, like that. Okay, right. So we will just see how they behave here. Examples are clearly given. We can quickly walk through this. Filtering methods. These are, I think, update methods, right? These are update, probably. Now, this is how collect is applicable. You can see, sir, I have a list of elements here, and I am applying collect on that. And you can see here, inside collect, we are applying a case concept. What is that we are doing now? On this collector, we are trying to apply some business logic here. If you see, if every number is an integer, then, sorry, not integer. If every number is an even number, then I want to return that. Means what? Collect internally applies some function, which is an anonymous function here, and that function is written back here. You can see wherever you find arrow mark, internally there is a lambda. Okay, so of course this is case. We are applying a case I. Inside case, right, case construct, what we can do, we can apply these things. Okay, you can do the comparison here. You can see we can apply a condition here directly with that case. On that condition, what is that? We are seeing something. If it is even, return this. We can also use this like this. This is how collect can be applied. Apply some predicate, some condition on some data, and finally fetch that data after applying the condition. That's what collect is. Is that clear now? So what happens? You get all even numbers, nothing more than that. This is flattening. I don't think you need a big discussion here. We have two lists. All these elements are merged into one list. That's all. And third one, map. Right, we are just trying to convert this each string to here, right, this list has strings, collection of strings, and we are trying to convert each string to uppercase, totally to the uppercase. But it's not just applicable only for conversion of uppercase. You can apply a business logic as well on each element. It's not just applicable only on strings. If required, you can apply this on even integers or decimals or any other type of val types. Okay, right. got it right. But here for analysis, for the sake of analysis, we're just trying to convert each string to uppercase here. That's what this does. Right? How this works here, map. No, you have a list here with four strings. You don't need to think them as two strings. We have four strings because we are applying a flatten, and on top of that we are applying map, so that all these elements are is collected into one list as a whole. Now you have four elements in that list, four strings. Now what happens is f represents the parameter. Every time this map is going to iterate starting from Mano to Vijay. So first it will fetch the first attribute into f. On that f, this logic is applied, f dot to uppercase. Then Mano gets converted to completely uppercase. Then again it will fetch Vida. Again Vida is converted to uppercase. Like that, it iterates every element in a list or every element in a collection and apply a business logic on that. And finally, we get some response on top of it. Got it right? Flat map is applying I don't think we can say flatten dot flat map. In place of this, if we just apply flat map, it is more than enough. But still, we will check it one more time after this. Flat map is itself is a flatten plus map. Updated, update. Right, we are applying this on A here, not on S. We have two lists here. One with the string list. The second one is with elements here. So we are applying updated on A. The first, we are trying to put the index here. That first index should be updated with 500. Probably the first index. Where is it? 0, 1. 5 should be updated with 500. Of course, it is immutable. You might get a doubt like how come you are able to modify it. See, when I try to update it with 500, it will altogether create a new list. All these values from the old list is copied to new list, and this instead of 5, it will copy it to 500. That's what happens internally in the memory. Okay, a new object is created, and as per index, every value is extracted and put it into that new object. In place of 5, it will try to put 500. So it's a whole new object when you try to get this updated. Okay, it's not the old one. Okay, so that's what we get here. Union means just right. S dot A means you are mixing the strings with that integers list. So that's what union is combining. Okay, both the lists. And then distinct means I don't need to explain that. Let me quickly test this scenario. Okay, any questions on this? Any questions? Same thing. Every iterator works the way what we have discussed, but the behavior might change. Suppose map applies condition on each element. Filter doesn't apply condition on each element. Okay, it might skip because that is how filter works. Reduce is there. That gives some other kind of functionality like that. Now you see that. Got it right? The first one is as usual. We are getting. Can you see that? Collect is giving all the list of here even numbers. That's what collect does. Then after that, the actual what is it? The actual list of lists. Then this is flattening. This is flatten. You can see both lists are merged into one single list here. Then converting to uppercase. Map is applied here. Then flat map. Okay, flat map means we apply flatten on top of that. Again, you remove this flatten. You see the difference. 1 minute, let me just see the difference. Okay, there is a small build error here. Probably I should remove one more closing brace. We need it. So it is expecting flatten here. Is not a member of list. Okay, so flatten returns list on top of that you are applying. So this, so that's this is working. 1 minute. So this is fine, but okay, it is trying to again split this string into. You can see there each individual letter. Okay, that's fine. But my thing is I just want to remove flatten and test it. That's what I'm seeing here. Brackets. We have any extra brackets, closing. Okay, this is perfect. It is saying uppercase is not a member of. Okay, got it. It is trying to get this list. On list we cannot apply to uppercase. You got it right. So even though flat map applies flattening and map, so the issue is what is happening here. It is trying to directly get it list here. So definitely what's happening is if these are strings, okay, these are strings. Let me just show you what's happening is this is f is getting list here. You know, when I do like this, you know, why this is there is an error is it is iterating, it is straight away giving us list here. On top of list we cannot apply to uppercase. But all if I should apply this, it should be string.
Manohar, sorry to interrupt. It's s dot flatten dot flat map.
Correct. We have tested it, but my point
Okay,
is,
okay.
As flat map has both flatten and map, because I am trying to see if it works in one shot without doing flatten. You got my point?
Got it.
So, but actually it's throwing an error. What is the reason here? The reason is simple. Here, it is trying to get here list here. That's why it's saying value to uppercase is not a member of list. Means what f is getting what here list. It is iterating list and giving list to this parameter. It is not giving string actually. I am thinking it will perform flattening on this, and after that what happens? It will extract string and pass to this. That's what I am assuming. But here this function is not working as per my expectation, because I cannot expect like as I like it works as per the API. So the API needs flattening first and then flat map after that. Okay? So that is the error why I am saying. So first flattening is necessary when you have a list of objects. Suppose just for analysis, I am removing this list here. Now I can, if I don't put lists here, okay. Now if I directly apply flattening, definitely this time we don't see an error, because to uppercase we are trying to iterate what. Okay, you can comment this for a while, okay, because that's not something to be worried for us. Now this will work. Why? Because earlier we don't list of lists. When I iterate, it is trying to get list and pass that as a parameter to f. Now you have all the list of strings. Now directly f is, you know, we are going to pass string directly to the f. This will work. Now when you run this, let's see this now, what happens, right? So see there here, what's happening here? Flatten is again flattening each string into letters. Again this one flat map is, you know, doing flattening and converting it to uppercase. That's what happened here. Can you see? This is what flattened is. Clear now? A string is converted to each element, individual elements there like characters, and on top of that it applied uppercase. Right? Got it? Just to, you know, right, give that insight, I just took this. I'm putting back as usual. Okay, this is fine. This works. Updated is fine. You know, right? What did we do? Where is that? You can see there 5 is replaced with 500, and then union means it merged both the list into a single list. You can see there here, if you can see, merged both lists, that A and S list into single list. And distinct means, you know, right, it allows duplicates. Sorry, it remove duplicates, no duplicates. That's distinct. This is clear, right? So I think we are already, you know, past that time. So tomorrow probably we finish up this, sir. Probably we don't have more after this. More instances, more are there, but still we will close this tomorrow. See, you have so many, and whatever we have done, this flat map filter, you keep, even I keep repeating them so that it might register in your memory. So next time when you are working with Spark, it will become much more easier for you. There is so much of important methods. We might think, you know, skipping this, but later on, after a while, you might feel that you would have done this. That's my opinion. But still, no, right? So this is the idea about this. You can see, but most of these methods again they will be recurring, so that you don't need to right spend more time on analyzing these methods again and again. You can see here again. See in this list, you can see there are so many methods which we have already discussed. Collect, right? Diff you don't know, but still easy to difference. It gives difference of two lists, right? Distinct, flatten, flat map, map, reverse. It's not difficult to understand. Just reverse the elements. Sort with nothing difficult. Okay. Updated, union, collection, zip. Okay. Sorry, not collection. Zip and zip with index. Anyhow, when you look at that, now it's fast for your mind to right to read this and understand these things. Okay. Even when you go down, you can see again few methods will be recurring. Okay. And if you see here, okay, some of these are anyhow new for us. Might be here again. There are certain things like which you can easily understand with the flow. Contains just checks whether an element exists inside a list or not. Contains slice means a part of list. Count means number of elements in the list. Ends with what string it ends. It will see return true if it is false or not. Exist, just see whether an element is there or not. Okay, and then find, right. And for all, it's more like again like collect kind of method here. Okay, or next one has definite size. And about again index of means returns the index of again overloaded methods. You can see index of slice, index of again, these are all overloaded, and these are little different from what we are discussing. So lost index of most of I think these you can ignore, folks, because I don't mean we are going to miss them, skip them, but mostly it's very rare that we use these methods in Spark. Okay, but for analysis purpose, we will quickly run through these methods once. Okay, so but still I had made right, you can see there I skipped a few of them here. If you look at this remaining, okay, so whatever important I put it there, remaining I skipped them. Okay, because I don't think most of them will keep coming to us. Okay, probably tomorrow we'll close it, sir. I'm sure tomorrow is the no, last instance, not for our Scala, but this is this list thing, we will close it tomorrow. Okay, are you good? Probably today you want.
Can you copy and paste that code, bro?
Yeah, sorry, I didn't see your message, Madhu. I'm copying and pasting. I think today we had a good session. To be frank, I feel this is again one of my best sessions we have done so far. Okay, more energy is there. Okay, correct, Madhu? So any questions, sir? We are done, sir. Any questions? Folks, Prasad or Sudarshan and Sri or Madhu or Deepak, Bharat sir, any questions? Sandeep, are you good here?
Yeah, Manohar. As of now, it's good. So thanks.
Yeah. Just be little patient, sir. Definitely, we will try to get little deeper and try to have hands-on on all this. After this, we'll talk about tools. Not now. Once we finish Spark. Okay. Then after that, also I will talk about the real-time scenarios like how to connect to Spark to HBase, Spark to Hive, Spark to RDBMS, and Spark to any other things. Okay, that scenarios we see, and we also see some scenarios which are usually prevailing in most of the projects. Right? Most of the this big data projects have a similar kind of architectures. Most of, I am not saying every big data, the kind of tools they use in most of the projects are similar. So if you understand these things properly, I don't think it is difficult. Also, one more important point before signing off today, I would like to tell you. See, big data is very interesting, sir. like comparative to many other technologies, because it's a mix of blend of, right, so many you name some technology that exists in big data. You take some database, it is there here. You take programming, that is there. You take about some other, I told just in the beginning of session. So point is, if you can, be patient and try to get into the shoe of these things, definitely you can do really good and enjoy the big data, this thing, okay, journey. Right? And many companies still are in the process of migrating to big data. You can see almost all, okay, many companies still now, many MNCs, many startups, many middle level companies have big data projects. Got it right? So that's the point. You are saying something like, tell about monad object. I didn't understand this. What is monad, Sandeep?
Sir, in one of the website I seen that is what is my monad in Scala like that. So that's why I asked if you know that.
You have seen in Scala, huh?
Yes, sir. In some of the interview questions, I have seen that monad in Scala like that.
Okay, fine, no issues. I will just explore and update you, because I am not exactly sure of what is that. Okay.
Okay.
Okay. We'll talk on it tomorrow. Thank you, folks. Good night.
Okay. Good night. Thank you.